Time to do more factoring, and this one is the worst of all of them. The first one was common factoring, so this kind over here, where you look at what the things have in common, where the number of terms stays the same, but you wind up with something in front of a bracket, and the same thing is, this would be 2y minus 3x, and we looked at that in a previous video. The second one was this kind of trinomial, which you know turns into two brackets that look like that, an x over here, an x over here, and we looked at how you find the numbers that go here and here, and there's a system to it, which we discussed in another video. And the next kind, which is the hardest and the hardest to remember, is what happens if I put a number here. You might have been wondering when you learned about the ones with B and C, why we skipped the letter A. Well, we were saving it for this because this is a pain. So what kind of thing makes a trinomial that looks like this? Well, it comes from two binomials, where there is, say, an x there and an x there, but you also have numbers. So say, for example, 3 and 2. And you distribute. Like this. And this would be 6x squared plus 8x minus 9x minus 12, two like terms in the middle. 6x squared minus x minus 12. And the question is how to get from this to this, because it's not entirely obvious how all of those numbers, the 2, the 3, the 3, the 4, came together to make the 6 a -1 and a 12. And I will not lie to you, this is extremely hard to do, and there is no good way to teach it except to just do lots and lots of examples. So all I will do is do examples, and you will notice there's a pattern coming through all of them, and you can start to apply that pattern on your own. So if at any point you think, I've got the hang of this, pause the video and try and work a few steps ahead. In the last one, it was all based on looking at the last number and making the list of ways to make 5 by multiplication, which in this case was 1 times 5, except for these ones, that won't work. So instead, I want both the first and the last number, and I want to look at their product, 2 times 5, which is 10. And I make the list of ways to make 10 by multiplication, and again, go in order so you do not skip any. 1 times 10, 2 times 5, 3 doesn't work, 4 doesn't work, 5 does work, but I've already written 5, so I'm done. And I want to take 2 of those numbers and put them together to make this -9. 2 and 5 will not work, but 1 and 10 will. And the way you do that is -10 plus 1. Now something a little bit strange happens. The next line, the first term stays the same. The middle term is going to become 2 terms. It will become this -10x plus 1x, and then -5. Why am I allowed to do that? Well, because if I gave this back to somebody who was just learning how to do the distributive property, collecting like terms, all of that, they would say -10 plus 1, that's -9x. So they're the same, it's just this is a more complicated way of writing it. Why did I choose that random way of writing it? Well, let's find out. Now you divide this down the middle. this should be minus 10x. You divide this down the middle and look at each one separately. So if I only look at those two and ignore what's on the other side, these have a common factor, 2 and x. If I look at this side, they don't have anything in common, so I'm going to say they have times 1 in common. But now I have two terms, and each term has the same ending, bracket x minus 5, bracket, which means I can pull that out to the front, open up a bracket, and now that this has sort of been looked after by this, I'm left with 2x and plus 1. So that is how you take this and factor it. And you'll notice it took 3 times as much work as the last version of factoring, and it was a little bit more difficult. And if you aren't sure whether or not this is actually true, do this back the old-fashioned way. That is 2x squared plus x minus 10x minus 10, like terms minus 9x. So yes, in fact, that is the same as that. That is factored correctly. So again, it's not very useful to try and explain why any of this works. It's just good to know that at some point somebody who was really smart noticed that it worked, and we can keep using their solution over and over and over again. So let's start this again. I look at the first number and the last number. 6 times 14, which is 84. And now I have to make the list of ways to make 84 by multiplication. And there is no shortcut. This is absolutely boring. This is absolutely tedious. If you want to reach for a calculator to do some of this faster, by all means, but this is the way to do it. 1 times 84, 2 times 42, 3, yes, would be, let's see, 28. 4 times 22. 5 does not work. 6 does work. 7, yes, times 12. 8, no. 9, no. 10, no. 11, no. 12, yes, but I've already written 12. That means I'm done. And I now want to look for something that adds to minus 17. That doesn't work. 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 And of course, the problem is that I don't know how to divide. So that really should be 4 times 21. If you noticed, good catch. And this is why. If you miss the one that matters, the questions actually become impossible to answer. I can take 21 and I can make negative 17 by doing minus 21 plus 4. And I'm not editing that out. I'm leaving that in because it's the sort of thing that happens and it's the sort of thing you have to learn how to deal with. So first term stays the same. Middle term splits using those two numbers, minus 21x plus 4x. Why is there an x there? Well, because I'm splitting some number of x's. If I have 17 apples and I split them, I still have 2 groups of apples. Minus 14 stays. I imagine a line down the center, and I look at each half separately. If I look at just the first half, both of these are divisible by 3 and x. 2x minus 7. And both of these are divisible by 2. That created me a situation where both terms end with the same bracket, which I can yank out to the front. And once that has been taken care of, inside the bracket, I'm left with 3x plus 2. Now, the question you might be asking is, does the order of these two matter? So let's keep the answer that we had. And instead, take away all of this. And instead of doing the minus 21 first, let's see what happens if we do plus 4x minus 21x. And same steps and see what happens. Imagine a line down the middle. Look at the first half. Both of these divisible this time by 2 and x. And this is 3x plus 2. And look at the second half. Both of these are divisible by 7. And one hint I will give you is, if the first term starts with a negative, you take the negative, always. This leaves 3x, and because I took the negative, this is now plus 2. And now, oops, I'll put that there, both of these end with the same bracket. I can pull that in front, and I'm left with 2x minus 7. So, in a sense, it doesn't matter which of the two of these you decide to put first. Whether you change the order, all that does is, instead of putting the 2x minus 7 first, it puts the 2x minus second. Instead of this being first or second, it just flips it. Everything still works just the same. So, another example. This one, you notice first, if you read this, that 30 and 21 and 3, all of those are divisible by 3. So let's do this. 3 10x squared minus 7x plus 1. Okay? Now, this is good because as far as the question is concerned, I can more or less pretend that this 3 is not there. Every line will just start with a 3, and I can do the same steps to deal with this. So look at the first number, the last number. That is 1 times 10, which is 10, and make the list of ways to make 10 by multiplication. 1 times 10, 2 times 7, 2 times 5. It's been a long day. And I want to put those together to make minus 7. That's going to be the 2 and the 5. We're going a little bit faster because we're getting the hang of this. First term stays the same. Second term splits. How do I put 2 and 5 together to make minus 7? That's minus 2 and minus 5. So minus 2x minus 5x plus 1. And imagine a line down the middle, or draw a line down the middle if it makes it easier for you. This part doesn't do anything. The first two, divisible by 2 and divisible by x. That would leave 5x and minus 1. Second two, nothing in common, but if there's a minus, I always take the minus. So what they have in common is minus 1. 5x minus 1. If it bothers you to have brackets inside of brackets, you can make these brackets square. So you have some way of telling them apart and reminding yourself that they're separate. This pulls out to the front. Let's clean that up. That leaves the 2x and the minus 1. And if you think about the way multiplication works, order doesn't matter in multiplication. So if I do this times this first, then times this, it's the same as doing this times this times this. So those brackets don't matter. And if you're really curious as to whether or not that all works, pause the video and you can distribute all of this back again to see, does all of that work and does it all give you that? Another example, let's keep going. And by now you're getting the hang of it, so we'll start to do this in more like what is just the real actual speed that you do it. First number, last number, 8 times 3 is 24. The list for 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I've written the one for 24 so many times, I know I'm done. That's it. Putting together to make minus 2 doesn't work, doesn't work, doesn't work. Yes, it does. Plus 4 minus 6. So 8x squared. This splits. I do like the lines of splitting them because it actually shows you where each piece is coming from. Imagine a line down the middle. Look at the first half. 2 and x can be pulled out. Oh, I take that back. 8 and 4, you can pull out a 4. So that would be 2x plus 1. And looking at the second one, take minus 3, 2x plus 1. Notice the bracket at the end of each term is the same. Pull it out to the front. Be left with 4x minus 3. Okay? And now to practice. So all of these questions, which I pre-wrote for myself, because if you take 3 random numbers, the odds that you are going to be able to pull this off are actually pretty low. So the way you practice this is you get together with a friend. So each one of you has to do 2 things. First, you number some questions. And you make 2 brackets. If you're really bored on a Saturday afternoon, this is a great way to make a friend using math. And you pick some numbers. So 3x, 2x, x, 5x, 2x, 6x, 3x, 4x, minus 1, minus 2, minus 5, minus 7, whatever numbers you want, plus 3, plus 4, minus 9, plus 1. And now you do these 4 questions. So take a piece of paper, do them, distribute. You get the idea. But now you have 4 answers. And you copy out the 4 answers, just the answers, and give them to a friend. And their job is then to work backwards and try and figure out what it was at the start. And you don't show them this, and you can give them, and they can do the same thing, and they can give theirs to you, and then you can trade back at the end, and then you can compare notes, and you can see if you actually got it right. And what that does is it makes sure, because you came up with nice numbers, it means that every question over here that you give to your friend will actually have an answer. Every question they give to you will actually have an answer. And, you know, at the end, randomly on one of the questions, change one of the numbers randomly and see if it works. So maybe there's a random one in there, and it comes up with D and F. Actually, let's do that. Let's pick some numbers at random and see if we can find one that doesn't factor and see if we can actually find one to see how that works. So if the instructions are factor, and I will do 3x squared plus 5x plus 4. Okay, so the way I do this is I look at the first number and the last number. 3 times 4 is 12. I'm really hoping this doesn't work, otherwise I'm going to have to re-record this. 1 times 12, 2 times 6, 3 times 4, done. Can I put a 1 and a 12 together to make 5? No. Can I put a 2 and a 6 together to make 5? No. Can I put a 3 and a 4 together to make 5? No. So if I made the whole list, and I've checked the whole list, and I can't find something to make this work, the answer to this is does not factor. And that is the only way you can actually be sure that it doesn't have a right answer, or it can't be factored, is if you actually go through the list, and more importantly, that you've actually got the whole list. So if you left one off because you were in a hurry and you were rushing, and that one happened to be the answer that worked, then the whole thing is just wrong. So hopefully you can go and give that a shot. I know it's going to be a lot of work, but if you do enough of them, it will start to work out. It will be okay. And if you have a specific topic that you want me to look at, just leave a mention in the comments and we can put together a video. And good luck doing your math homework.